Okay, the 25-minute question from your FRQ 6. Reminder that these were created by a gentleman who decided to make a rubric worth 15 points. And so that's what we're going to be operating under as we walk through this. As always, if you have any remaining questions at the end of this video that have not been effectively answered, please feel free to reach out and ask. I'm definitely here to support you with whatever it might be, even if it's grading the problem or I don't know. Let me know. I'm here for you. Okay? So here we go. Because of recent problems at the site, a central highway in a town in Pennsylvania is being covered with dirt so that people will not trespass on the property. This is a huge undertaking, expecting to take 14 days. For the first 10 days, so I'm going to go ahead and write that as 0 to 10 just to remind myself. Dump trucks will bring dirt to the location at a rate, so we know we've got a rate here, of RFT cubic yards per day. So again, kind of referencing that rate idea. That sounds kind of like velocity almost, right? Like miles per hour, cubic yards per day. It is known that RFT is always greater than 0, so positive. Certain values of RFT are given on the table below. After the first 10 days, the dump trucks will be replaced by a conveyor belt. So from 10 to, I don't know, infinity. So after the first 10 days, the conveyor belt then will move the dirt at a rate, so again, derivative of some sort. C of t, again, we see that cubic yards per day, referencing those velocity units, right? Okay. A, using the data from the table, find the best approximation of r prime of 8. So this originally comes out of Unit 2, but we reviewed it in our particle motion unit. It's also been in quite a few videos at this point, which is how do we approximate a derivative or a slope when we're given a table. Okay, well, a derivative or a slope, remember, is the same thing it's always been, rise over run, change in y over change in x. And so to approximate a slope at 8, we're going to be doing change in y over change in x. 8 would lie on that interval there. And so I'm going to go ahead and do r prime of 8 is approximately either 400 minus 320 or 320 minus 400, whichever one you prefer. But whichever one you put first, its x also needs to go first. So since I put 400 first, 10 is going to go first. And then remember, you don't have to simplify, so you can leave it there, or you can make this 20, whichever one you prefer. Okay? Include the appropriate units to your answer. So we're doing r prime. So r was cubic yards per day, right? This is kind of like velocity. I'm going to go ahead and put velocity under here. So if I took the derivative of r, or the derivative of velocity, what would I have? Well, I'd have acceleration, right? Acceleration has units of distance per time squared. So in this case, this would be cubic yards per my time day squared. You're going to see this some more as we continue to practice. You'll interact with this idea more and more. Every time you take the derivative, a time element gets added. Every time you take an integral, if I were to integrate this, a time element would get removed, right? If I were to integrate r prime, I would have r. So I'd be removing a time element, yards cubed per day, which is what r was. If I were to integrate r, my units would then be just cubic yards and not cubic yards per day. Right? And again, we wrote all of that at the top of your first page of your particle motion packet. Okay, this one was worth 2 points. 1 for your answer, which again didn't have to be simplified, so I'll put the +1 in between, and then 1 for your units. Okay. B, I really liked B. It's the only example I have of this kind of thought process. Is there guaranteed to be a value of k on the interval 0 to 10 such that r prime of k equals 0? Explain your reasoning. So we're looking to guarantee some sort of derivative, so we're thinking MVT. And I like this one because it's one of the few examples that I have of when our answer would actually be no. No, I can't guarantee it. And it actually has nothing to do with the coordinate points. There are definitely, I'm sure, people out there who are like, oh, well, but if you did like r of 10 minus r of 0 over 10 minus 0, wouldn't you get 0? Because 400 minus 400 would be 0 in the numerator. And you would, yes, but there's one other thing you always have to check with your function. MVT is in 3.2, and we've talked through MVT over several different videos, but to apply MVT, you have to be differentiable and continuous. Well, nowhere in this problem are we ever told that r of t is differentiable. All those words up above, not a single one of them stated anything about differentiability or continuity, right? And so no, we actually can't, because we do not know that r of t is a differentiable function. Okay, this was only worth 1 point for your answer with reason. Okay, C, we have using correct units, explain the meaning of the integral from 0 to 10 of r of t dt. Use a right Riemann sum with the 4 subintervals in the table to approximate the value of 0 to 10 of r of t dt. Okay, so let's go ahead and explain our meaning first. So let me slide this up. 0 to 10 of r of t dt is, okay, and then there's lots of ways you could explain this meaning. So I'm going to write my way. It's not necessarily the only way, so if you wrote it a different way, feel free to run it by me. I'm more than happy to confirm that it is in fact correct, or to help you tweak it a little bit to make it work. But I think I've said this in a previous video, I like describing integrals in terms of totals, because that's what an integral is, right? We reviewed that the very first FRQ focus day we did, right when distance learning started, the tabular data one. So an integral is a total. 0 to 10 of r of t dt is the total, and total what? Okay. Well, it's the total dirt in yards cubed, because that's how that's measured, brought to the location from, and remember I said in previous videos, always make sure you reference the time, from t equals 0 days to t equals 10 days. Okay? If I'm describing a derivative, I like using the word rate. Integral, I use the word total. Okay? And then a right Riemann sum to approximate, so 0 to 10 of r of t dt to approximate. 4 subintervals, so we see these up here. 0 to 2 is 2, 2 to 5 is 3, 5 to 6 is 1, 6 to 10 is 4. Okay, so first subinterval, distance of 2 times my right, which is 420. Second one, distance of 3 times my right. Third one, distance of 1 times my right. And fourth one, distance of 4 times my right. And I would leave it alone. Don't simplify, there's no reason to. Okay, this one was worth 4 points. 1 point came from your, let me look at the rubric here, came from your explanation, so noting that it's the total dirt brought from 0 to 10 days. And then another point came from your units, so I'll go ahead and put +2 in there. Again, 1 for the explanation, 1 for the with units. And then 1 came from your Riemann sum and 1 came from your answer. So again, I'm going to put +2 because in this case our Riemann sum is our answer. However, if you had simplified correctly or incorrectly, right, so you set it up right but simplified wrong, you'd get 1 out of 2 points. If you made an error in setting it up, but then left it alone, you'd get 1 out of 2 points, again, as long as you didn't oversimplify the problem. Obviously, if you set it up wrong and then make a mistake while you simplify your wrong setup, you now get 0 points. So again, a reason to not simplify, but 2 points in there. 1 for the Riemann sum, 1 for the answer. Okay, part D is up next. Parts D and E, I actually feel like are the most challenging of this particular one. Again, you might disagree. Not really the explanation so much. It's with D, it's the fact that you have to set up your own table for your trapezoidal sum. And as I've done with videos in the past, I went back and forth about whether or not to alter D a little bit. I actually haven't yet found a problem where you have to set up your own table. I think I mentioned that back in Unit 4 when we learned this. And so I thought about creating a table for you so you didn't have to set up your own, but I was like, you know what? This is a weird year. It's a good thing to kind of remind ourselves of how that looks just in case. And it gives us a chance, honestly, to practice the emotional side of this, which is, again, one more time, College Board creates problems that push the limits of students to see, do they persevere? Can they think outside of the box? Can they keep going? Even if they hit a problem where they're like, oh, I don't remember how to do this, or I don't remember if I ever learned this, or, you know, like you can't panic. You can't let that throw you. And so I went ahead and assigned this because, like I said, it gives us a chance to kind of go, okay, I don't remember how to do this. Let me put down what I can think of related to this problem. Maybe it's like setting up the trapezoidal sum bit, but maybe leaving some things blank. Maybe it's doing the explanation. Like you want to throw down what you can related to the problem. Don't leave it blank, and then move on. Don't let it throw you. Okay? So that's why I went ahead and still assigned D, even though I do think it's a little out there. Again, not the explanation part so much. It's the having to set up your own table for the trapezoidal sum. Okay? So the explanation, real quick, explanation is going to be pretty much exactly like what we wrote in C, just different days. So this is the total dirt in cubic yards brought to the location from t equals 10 days to t equals 14 days. And then we have to do a trapezoidal approximation, but we don't have a table. So we need to give ourselves a little table here. (10 to 14). Okay. And so then C of t at 10, C of t would be 400 over 10 minus 9, which is 400 over 1, or 400. At 11, 400 over 11 minus 9, 400 over 2, 200. 400 over 12 minus 9, 400 over 3. 400 over 13 minus 9, 400 over 4, or 100. And 400 over 14 minus 9, 400 over 5, which is 80. And so then we can do our trapezoidal approximation. So 1/2, not the left, not the right, but both. So 400 plus 200 times the change, which is 1. 1/2, 200 plus 400 over 3 times 1 plus 1/2, 400 over 3 plus 100 times 1 plus 1/2, 100 plus 80 times 1. And again, don't simplify. Waste of time. Okay, so this one was also worth 4 points. Same initial 2 points, one for your explanation, one for including appropriate units. And then same final 2 points, one for your trapezoidal sum and one for your answer. With, again, the same breakdown of partial credit there. So if you did mess something up with the setup there and you're not sure if you still would get your answer point even though you set it up wrong or whatever, send me a picture. I'm more than happy to check it for you. But there you go. Okay, E and F are both worth 2 points. We've got 2 remaining for each to walk through. E is the approximation in part D, an overestimate or an underestimate. Explain your reasoning. Okay, we've done this in 2 different videos now, so here's a third one. This has, I'm going to actually do it in red off to the side here, has everything to do with concavity. So if we were concave up, and actually I guess we've done this with the tangent line. The left hand, right hand, all that happened also. It's been in 2 different videos. Originally the tabular data one, and then it was in your sample exam. I don't remember. In one of your sample exams there was one that made you like compare the left hand, right hand, mid or trapezoidal and actual. And again, I can find that for you if you want specifically that one. But so coming back to this, if we are concave up, a trapezoidal which connects one end of the interval to the other, it would be an over approximation. If we were concave down, trapezoidal which connects one endpoint to the other would be an under approximation. And so the question is, are we concave up or are we concave down? Well, what does it mean to be concave up? What does it mean to be concave down? To be concave up means your second derivative is positive. To be concave down means your second derivative is negative. So we need to see, well, if C is 400 over t minus 9, what's my second derivative? Okay, so first derivative, we have low d high, which would be t minus 9 times 0, so nothing, minus high, 400, d low, which is times 1, all over low squared. Okay, and then second derivative, we have low d high, which is again going to be times 0, so I'm not going to write it, minus my high, so that's going to make that a positive 400, d low, bringing down the 2, subtracting 1 from the exponent, times the derivative of the guts, all over low squared, which is 400 times 2 is 800. And 1 t minus 9 up top would cancel with one of the ones on bottom, leaving me with 3 t minus 9s on bottom. And so what does that mean my second derivative is for this interval? No matter what number I plug in for 10 to 14 here, this second derivative then is always positive. My function is always concave up. And so my trapezoidal is an overestimate. Because my second derivative is positive for 10 to 14. Okay, again, this one was worth 2 points. 1 was for considering your second derivative, recognizing that my concavity determines whether or not I'm an over and under approximation. And so maybe you weren't even sure how to figure out if it was an over or an under, but you're like, well, concavity usually has something to do with it. And so you took a second derivative because maybe you were a little stuck on it. And so you do something that you can think of related to the problem, right? You still would have gotten a point for considering the second derivative. And then 1 came from your answer with reason. Okay, last one, find the exact amount that the conveyor belt brought. So instead of an approximation, we're going to go ahead and find the exact amount. Let me go ahead and put my C of t in. Okay. And so integrating this to the natural log. Plugging in the upper, we would have 400 times the natural log of 5, minus plugging in the lower, 400 times the natural log of 1. And again, you can leave it alone. I would, or you can simplify a little bit further to 400 natural log of 5. Okay, 2 points. 1 came from the integral, and 1 came from your answer. Okay, if there are any questions still related to this problem or the other 3 in FRQ 6, let me know.